Hey everybody, welcome back. We are going to do some more practice with the rational root theorem today. So we use that theorem when solving equations with a degree greater than 2. So like number 1 has a degree of 3, which means there are actually going to be 3 roots. So we're going to use the rational root theorem to find them. Okay, so we start with Q, and Q is plus or minus all of the factors of the leading coefficient. The numbers that go into 6 are 1, 2, 3, and 6. And then P is plus or minus all the factors of 10, the constant term. 1, 2, 5, and 10. Okay, so P over Q is all the possible rational roots of this equation. Okay, so P over Q means all the P's over all the Q's. So all these P's over 1, 1, 2, 5, 10. All the P's over 2, 1 over 2, 2 over 2, which is 1, we've already used that, 5 over 2, and 10 over 2, and that's 5, and we've already used that, so we don't have to rewrite that. All the P's over 3, so that's 1 over 3, 2 over 3, 5 over 3, and 10 over 3. And then all of the P's over 6. 1 over 6, 2 over 6 is 1/3, so we've already done that. 5 over 6, and 10 over 6, and that's 5/3. So we've already done that as well. So that's my list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. And also the negative version. So positive or negative means I've actually got 24 possibilities here. Okay? So I need to check on my calculator. I don't really have to use a calculator. I can always just start plugging these numbers in, the positive version and the negative version, into this equation. So if I don't have a graphing calculator, that's what I'm going to have to do. And anything that gives me an output of 0 is a root. Okay? If I have a graphing calculator, it's much easier. There's free graphing calculators available online. Desmos is a good one that can be used. This is an emulator for a TI-84, so this one works out for me. So what I need to do is plug in my equation. So y equals 6x cubed plus 13x squared minus 3x minus 10. Okay, that's what the graph looks like, and I can actually zoom forward and get maybe a little bit better look at it. This one right here looks like -2, so I'm going to trace -2 and see if that's correct. And it is. -2 gives me an output of 0. Okay, so x equals -2. This one here looks like -1, and that's an option. So I'll trace -1. And that gives me an output of 0. And this one here is a little less than 1. Something I have a little bit less than 1. The closest I have to 1, but less than 1 is 5/6, so I'll try that. 5 over 6 gives me an output of 0. And that's all the roots. There are 3 of them. And I found all 3 just from the graph. So we can move on to number 2. This one also has a degree of 3, so there's going to be 3 roots. Okay, now I should point out, this P over Q, what this is a list of all possible, and I'm going to highlight possible here, rational roots. Okay, I'm stressing possible because they can't all be roots. There are 24 of them when you include the positive and negative version of all of these numbers. There's 24 options here. There can only possibly be 3 correct ones. So these are all the possibilities we had to choose from, and we found the 3 that are correct. Okay, so here on number 2, there are going to be 3. We need to find a list of all the possibilities. So we'll start with Q, and that's plus or minus the factors of the lead coefficient, so 1 and 3. P is plus or minus all the factors of the constant term, 1, 2, 3, and 6, all go into 6. So P over Q is plus or minus all the P's over 1, so that's 1, 2, 3, 6. And all the P's over 3, that's 1/3, 2/3, 3/3 is 1, and 6/3 is 2, so that will actually finish my list. Okay, so those are all the possible rational roots. Next, we're going to graph the equation. I really should have cleared out that first one, so I'm going to start over. 3x cubed minus x squared minus 18x plus 6. And there's the graph. I don't need to zoom out because I can see all 3 of the x-intercepts here, here, and here. So I need one that's negative a little over 2. Negative 3 is the only thing that's over 2. Well, there's negative 6, but that's definitely too far. But that's not as far as a negative 3. And if I do type in negative 3, so trace negative 3, I can see that is not a 0, so that is not an x-intercept. So it doesn't look like I'm going to be able to find that one on my list. So let's move over and try this second one. Just a little past 0, maybe 1/3. So we'll trace 1/3. And that gives me a 0. So x equals 1/3 is one of my roots. It's one of my solutions. Over here, I'm looking at a little over 2, but not quite to 3, and I don't have any option like that in my list here. So another thing to stress up here is not only are these P's over Q's all the possible rational roots, but that word rational. This is a list of rational roots. If I can't find my answers all in that list, that means perhaps I've got some that are irrational. Okay, so here's how I handle that. Now, if I was factoring this, I would have found right now that I've got a factor of x minus 1/3 times something else. I don't know what that is yet. That x minus 1/3 is why one of our roots is positive 1/3. So I'm going to use synthetic division. I'm going to put 1/3 in front. And I'm not missing any powers. I've got cubed, squared, x, and a constant. So I don't need to put in any zeros here. So we've got 3, negative 1, negative 18, and 6. Okay, so I'm going to bring down that 3 and then multiply. 1/3 of 3 is 1. When I add these, I get 0. 1/3 times 0 is 0. Add these and I get negative 18. 1/3 of negative 18 is negative 6. I add those and I get a remainder of 0, which is good because if I'm saying that x minus 1/3 is a factor, when I divide by that factor, I better get a remainder of 0. Otherwise, I've made a mistake either in finding that factor or in my division. Okay, so I've got to have a remainder of 0 or else I've messed up somewhere. Okay, so I've got my constant x and x squared, so 3x squared, no x's, minus 18. That's this factor. And when I set that equal to 0, I can find the rest of my solutions. 3x squared minus 18 equals 0. We move that negative 18 over. 3x squared equals 18. I'll divide by 3. X squared equals 6. And then take the square root. X equals plus or minus the square root of 6. Okay? Those are two irrational solutions right here. Square root of 6, the opposite of the square root of 6. So my other two solutions are the square root of 6 and the opposite of the square root of 6. And those are my three roots. One of them rational, two of them irrational. It's the rational ones we can find in the graph, the irrational ones we have to do a little more work for. Number 3 has a degree of 4, so it's going to have 4 roots. Some of them might be rational, they might all be rational. There might be some that are irrational, there might even be some that are not real. Okay, so we'll start with Q, plus or minus all the factors of 3, 1 and 3. P, plus or minus the factors of 7, 1 and 7. So we're going to have a pretty short list here. P over Q is plus or minus the P's over 1. So that's 1 over 1 and 7 over 1. Then the P's over 3, so that's 1 over 3 and 7 over 3. Okay, now I'll go to my calculator. 3x to the 4th plus 11x cubed plus 26x squared plus 11x minus 7. And graph, I can only see 2 there, so let's zoom out. We'll zoom 6 for a standard view. Still only see the 2, so I'm going to go back to a closer view. Zoom 4. It looks like -1. That one looks pretty clear to me, so let's trace -1. And that is one of the roots. I have an output of 0, so if x equals -1 is a root. This one here, maybe 1/3, so trace 1/3, and we get an output of 0. Now the other two, I decided there have to be 4 because I've got a degree of 4, so the other two, either they're so far to the right or left that I just can't see them without zooming way out, or they're non-real, in which case they don't actually cross the x-axis. So what I'm going to do is divide again. So if I'm factoring this, I've got an x plus 1 and an x minus 1/3 and something else. I don't know what that is yet. To find that, I'm going to have to divide by both of these. Okay, since I've got both of those factors, I'm going to have to divide by those factors. I'm going to start with the integer. Okay, I don't see any missing powers, so I don't have to add in any zeros. Okay, I'll bring down that 3 and multiply and add and multiply and add and multiply and add and multiply and add, and I get a remainder of 0, so I did okay. Okay, now I'm going to do this again with the other factor. So I have the 1/3 out here, bring down the 3, so I'll multiply and add and multiply and add and multiply and add, and I get a remainder of 0 again. So I know we did okay. So I get 3x squared plus 9x plus 21. That's my other factor. And I need to solve that by setting it equal to 0. Okay, let's solve this one by completing the square. First thing to do when completing the square is get a lead coefficient of 1. So we get x squared plus 3x plus 7 equals 0. Okay, I'm going to have to bring that up to here. Move that c over, make room for a new c. X squared plus 3x, and then space equals -7 and space. Okay, so the new c is half of b squared, so that's 3 over 2 squared, so that's 9/4. little squeezed up against my division here. Okay, to factor this, I know it's a square trinomial, so if I just take half of b, I get x plus 3 over 2. It's going to be x plus 3 halves times x plus 3 halves, or x plus 3 halves squared. And negative 7 plus 9/4. 7 times 4 is 28, so this is the same as negative 28/4 plus 9/4, and that's going to be negative 19/4. Okay, so a square root of both sides, x plus 3 halves equals plus or minus the square root of negative 19 over 4. And now to simplify, I'm going to move this over and then simplify this radical. So x equals negative 3 halves plus or minus. And this square root of negative 19 is I times the square root of 19. Square root of 4 is 2. So my other two roots are non-real, negative 3 halves plus I root 19 over 2, and negative 3 halves minus I root 19 over 2. And normally I'd like to split that up into two separate roots here, but I'm going to run out of space really fast, so I'm going to just write them as one with a plus or minus that represents both. Negative 3 halves plus or minus I root 19 over 2. And one more. Q is plus or minus all the factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. And P is plus or minus all the factors of 40. 1, 2, 4, 5, 8, 10, 20, and 40 are all the numbers that go into 40. Okay, so P over Q, this is going to be a pretty long list. Plus or minus everything over 1. So all the P's over 1. 1, 2, 4, 5, 8, 10, 20, 40. All the P's over 2. 1/2. 2 over 2 is 1. 4 over 2 is 2. We don't have 5 over 2. 8 over 2 is 4. 10 over 2 is 5. 20 over 2 is 10. And 40 over 2 is 20. So we've got those. All the P's over 3. 1 over 3. 2 over 3. 4 over 3. 5 over 3. 8 over 3. 10 over 3. 20 over 3. 40 over 3. All the P's over 5. 1 over 5, 2 over 5, 4 over 5. 5 over 5 is 1. 8 over 5. 10 over 5 is 2. 28 over 5 is 4. 40 over 5 is 8. So we have those. Next is everything over 6. 1 over 6. 2 over 6 is 1/3. 4 over 6 is 2/3. 5 over 6. 8 over 6 is 4/3. 10 over 6 is 5/3. 20 over 6 is 10/3. 40 over 6 is 20/3. Now everything over 10. 1 over 10. 2 over 10 is 1/5. I believe we have 1/5 here. 4 over 10 is 2/5. 5 over 10 is 1/2. 8 over 10 is 4/5. 10 over 10 is 1. 20 over 10 is 2. 40 over 10 is 4. So those are all numbers that we have. Everything over 15. 1/15. 2/15. 3/15. I'm sorry, 4/15. 5/15 is 1/3. 8/15. 10/15. That's 2/3. 20/15. 20/15ths, I believe we also have. That simplifies to, let's see, 20 and 15 are both divisible by 5, so 4/3, and we've got that here. And then 40/15, we've also got as 8/3, so we can move on to everything over 30. 1/30, 2/30 is 1/15, 4/30 is 2/15, 5/30 is 1/6. 8/30 would be 4/15. 20/30, 10/30 is 1/3. 20/30 is 2/3. 40/30 is 4/3. So that looks like that is finally the end of our list of P over Q. So now we can finally graph. Okay, so 30x cubed. By the way, we did not write this. How many roots? It's a degree of 3. So there are 3 roots. Okay, I should have cleared this. So 30x cubed plus 83x squared plus 170x plus 40. Okay, so on my graph so far, I see one intersection. Let's just check out that one. So it's a little bit to the left, so maybe it could be something like 1/3, -1/3, not quite -1/2, -1/5, -2/5, something like that. What it's actually going to turn out to be, and I'll show you by tracing, is -4/15. Okay, so it could take a lot of guess and check before we finally get to that particular one, but x equals -4/15 is the rational root. Everything else is going to be irrational. If I zoom out to a standard view, we still aren't going to see any more intersections, so this one might even be non-real. So let's use that -4/15 and divide. 30, 83, 170, and 40. So we bring down that 30, and we multiply. -4/15 times 30 is -8. And we add and get 75. Multiply these, and we get -20. Add, and we get 150. Multiply these, and we get -40, and combine these, and we get 0, a remainder of 0. So 30x squared plus 75x plus 150, and we'll set that equal to 0. Okay, the easiest thing to get started is going to be to divide everything by something that goes into all those. I believe 15 goes into all those, so we'll divide all of these by 15 and get 2x squared plus 5x plus 10 equals 0. Let's solve this using quadratic formula. X equals opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Took that a little bit too far. Okay, so that's -5 plus or minus the square root, and that's going to be the square root of -55 over 4. Now, 55 can only be broken down into 5 times 11, so we're not going to be able to simplify that other than to take out that negative as an I. And once again, I'm just going to write this representing 2 separate solutions all in one. I'll break it up into 2 fractions of -5 fourths plus or minus I times the square root of 55 over 4, and those are my 3 roots.